Welcome to our third video on Class Notes 8-10. In our first video, we took a look at the first type of single displacement reactions, active metals replacing less active metals in solution. In our second video, we took a look at the second type of single displacement. That's where an active metal can replace a hydrogen ion in solution. And we also looked at the third type, where an active metal can replace hydrogen atom on a water molecule. So water molecules are HOH. In the third type, an active metal can knock an H off the HOH, leaving behind OH minus and the active metal in solution. Our fourth type, which is what we're going to be discussing in this video, is the final type of single displacement reactions, and this is where active halogens can replace less active halogens. Our most active halogen is fluorine. It can replace chlorine, bromine, or iodine in solution. Our least active is iodine. It can't replace any of the other ones in solution. Remember, halogens are looking for electrons. They're trying to become anions. The more active halogens are good at pulling electrons off the less active halogens so that they can get their 8 all by themselves, becoming a negative ion, an anion, and satisfy the octet rule. So more active halogens want to become an anion, the same way that more active metals want to become a cation. Active metals want to get rid of their electrons and be left full. The anions want to steal electrons in order to become full. So more active halogens will pull electrons off less active halogens. Let's take a look at an example. In this example, they're saying fluorine is going to be bubbled into a solution. Fluorine is a gas and it will be bubbled into a solution containing sodium ions and chloride ions. Can fluorine nonmetals replace chlorine nonmetals? So nonmetals will always replace nonmetals. Our activity series says fluorine is more active. On this particular activity series, where are these halogens on this activity series? They're right down here. The most active halogen is fluorine. The least active halogen is iodine. Really, astatine is the least active. So the ones at the top, the more active ones, can replace the ones at the bottom, the same way as we have it on our metals chart. So fluorine can replace the nonmetal chlorine. So fluorine will replace chlorine in the formula, and we will end up with NaF. Where do we get NaF? Sodium is in family Roman 1. It's 1 plus. Fluorine is in Roman 7. They need 1 electron to become 1 minus. We crisscross the 1 minus and the 1 plus. We end up with NaF. What will happen to the chlorines? Well, we know chlorine is diatomic. It's part of Brinkelhoff, so we'll end up with 2 of those joining up to form chlorine. It's the Cl in Brinkelhoff. So we have 2 chlorines here. We're going to need 2 fluorines or 2 sodiums and fluorines there in order to balance this thing. Why? Because fluorine is also diatomic. It's the F in Brinkelhoff. So when you are diatomic, you always have to have the 2 after that. So we need 2 fluorines. We put a 2 in front here. We need 2 chlorines. We put a 2 in front there. That will balance the reaction. What would this look like in a diagram? Well, we're going to bubble fluorine gas into a solution containing sodium chloride. When we have sodium chloride, the chlorides have sodium's electrons. So we have the sodium ion. Originally, it gave its electrons to chlorine to become the chloride ion. These reactions can only happen in aqueous solution. Aqueous means water pulls it apart. So up here we see NaCl, aqueous. Aqueous means we pull apart the ions. This is a salt. The sodium ions will be floating around. The chlorides will be floating around. And now we've bubbled fluorine gas in there. When we bubble fluorine gas in there, the molecules will be bumping around and the F2 molecule can actually break apart. Why will it break apart? Because fluorine is very active. It's going to want to steal that electron off the chlorines that were floating around. So the chlorides are floating around with 1 extra electron. They have sodium's electron. When the fluorines are bubbled in there, they bump around with the water molecules, they break apart, and since they're more active, they will rip off the electrons from chlorine. Gaining an electron, they become the fluoride ions, which are now floating around. The two chlorides each need electrons. They lost the electrons they had, which satisfied the octet rule. They lost it to the fluorines, who became fluorides, and now they need another one. What will they do? They will join up, and each of them will share, and they'll form that single bond in order to get 8. They'll become a gas, and they will bubble out of solution as Cl2. We can see that right here. So our ionic equation, F2 went in. It went into the solution of the 2 Na pluses and the 2 Cl minuses. As the reaction happened, the fluoride stole the electrons off the chloride ions. And now we have the F minuses floating around, as we see right here. The two chlorides join up to form the chlorine molecule, and they bubble out of gas, as we see here. This is our ionic equation. If we're asked for a net ionic equation, they want you to only show the ions or the things that underwent changes. Who didn't change here? I have Na plus here. 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 The Na pluses didn't change at all. They were spectators. Nothing happened to them. So when we want to draw the net ionic equation, we just get rid of the spectator ion. I have Na plus on this side. I have the Na pluses on this side. I cross those out, and I have my net ionic equation right here. Can chlorine replace bromines? Example 7. Can chlorines replace bromines? Let's take a look at our activity series. We can look at this one right here, where chlorine is more active than bromine. Or I can look on this one right here. Chlorine is above bromine. It is more active. So yes, chlorines can replace bromines. So let's take a look at what would happen here. Nonmetals replace nonmetals. So the Cls will end up with the Sr, replacing the Br, who's the nonmetal. Where do I get the formula? Strontium is in Roman 2. Group 2. They have 2 valence electrons. They become 2 plus. So I crisscross strontium's 2 plus down to the chloride. Chlorides are 1 minus. It's a halogen. Roman 7. They need 1 to get 8. I crisscross the 1 down to the strontium. SrCl2. Who did we displace? Br. There's the Br. Why do I have a 2 here? Not because there's a 2 there. The 2 here on the left side is because strontium's 2 plus. I crisscrossed it. The 2 here is because bromine is a diatomic element. It's the Burr in Brinkelhoff. Why is there 2 here? It's because chlorine's the K in Brinkelhoff. This 2 is not because of Brinkelhoff. This 2 is because I crossed the 2 down from strontium. The diatomic 2s only go with the ones that are in Brinkelhoff. Anytime we have a compound, we crisscross the charges when we have the ionic compound. So yes, this reaction happens. This is what we have. In example 8, they're asking, will it happen? Can iodine replace fluorine? Can iodine replace fluorine? We look up here. Iodine's the least active. It won't replace fluorine. Acetatine's actually less active, but it's really not an element that we use very often. Iodine's beneath fluorine. It cannot replace fluorine. So in example 8, it will be a no reaction. Iodine cannot replace fluorine. Let's take a look at example 9. Example 9, they're wanting you to write if the reaction will happen. Can magnesium replace iron in iron 2 sulfate? Let's take a look at our activity series. Magnesium's right here. Iron's right here. Magnesium's above iron. So yes, magnesium can replace iron. So this reaction will happen. So magnesium will knock off iron. Iron will now be by itself. Where do I get my formula here? Is it because there's 1 sulfate there, so I would only have 1 here? No, I have to crisscross. Magnesium's in Roman 2, it's 2 plus. Sulfate is a polyatomic ion. If you look on your polyatomic ion, you'll see that sulfate is 2 minus. We have a 2 and a 2. We would reduce those to a 1 and a 1, and then we would crisscross. MgSO4. When we look at our formula, or when we look at our equation, it is balanced. 1 magnesium here, 1 there. 1 sulfate here, 1 there, One iron here, one there. It is balanced. In our next one, can nickel replace zinc? Let's take a look at the activity series. Here's zinc. Here's nickel beneath it. That would be a classic no reaction. No reaction would happen because zinc is more active than nickel. In the next one, can bromine, which is a liquid at room temperature, replace iodine? So if I pour bromine into a solution containing sodium iodide, will a reaction happen? Yes, it will. Bromine's more active than iodine, so that reaction will happen. So Na will end up with Br. Br will replace the I. Bromide is 1 minus, sodium's 1 plus, crisscross our charges. Iodine will be replaced or displaced. It'll be by itself. Why do I have a 2 here? Because iodine's in Brinkelhoff. Why do I have a 2 here? Because of Brinkelhoff. Brinkelhoff. It's diatomic. So there's a 2 here and a 2 here. If I have a 2 here, I'm going to need a 2 in front. If I have a 2 in front, that gives me the 2 iodines I need. I have a 2 here, so I need a 2 in front of that to give me the 2 bromides. We are done with that reaction. With those reactions, we completed it and balanced it. In our next video, we'll take a look at example 10. And that'll be our final video over our 8-10 notes.